Welcome to the Crazy Hat Chemist. So another video here on electrochemistry. So let's get started. Bam! So today we are talking about balancing electrochemical equations number 7. Number 7, here we go. We're going to balance the redox equation below. Here it is. So we got KiO4 plus Ki plus HCl produces KCl plus I2 plus H2O. So again, like every single redox equation, what we need to do is assign oxidation numbers for every single element. Okay, so let's look at that first compound here. The potassium is in group 1, it's going to be a +1. The oxygen is oxide, and that's a -2. So therefore, we need to solve for the iodine. Here's the potassium at a +1, and the iodine, after solving for it, is going to be a +7. The oxygen is, of course, a -2. The next one is Ki. With K, that's potassium, is in group 1, just like I aforementioned on the previous compound, so that's a +1. Iodide is the halide ion, and that's a -1. Okay, HCl, I got hydrogen, that's a group 1, that's a +1. Chloride, that's a halide ion, that's a -1. Super simple. I've got all my reactants done now at this time. Now we're going to do the product. So the first product is KCl. Okay, K, that's potassium, is group 1, just like it was before, that's +1. Chloride is a halide ion, that's a -1. Okay, now then we have iodine, and iodine is a diatomic, and it is an element in its standard state. So it's an element in its standard state, and of course it's a diatomic because it's iodine, and then that is an oxidation number of a 0. Then we've done water before many times, and hydrogen is a group 1, that's a +1. Oxygen is a -2, so +1 and -2 there. Now what we're going to do is analyze this and find out what two elements are changing in oxidation number. Now this one is just slightly different in that we have two things that are happening simultaneously here, if you will. All the other reactions that we've had thus far, we have two different elements that are changing in oxidation number. This time, we don't have that. We actually have one element that's changing in oxidation number. Okay, so the iodide is the one that is changing in oxidation number. You should see on the reactant side, I have a +7. And also on the reactant side, I have a -1 for the iodine. And on the product side, there's only an iodine. Okay, and that is a 0. So there's a reduction and an oxidation occurring, reduction occurring with that same iodine. So a little bit unusual that what we have discussed so far, but it is most certainly possible. So this is the reduction half reaction that is going from the +7 to the 0 for the iodine. And then in the Ki, we also have an oxidation, and that's going from the -1 to the 0. So we actually have two reactions here with that one element. So unusual, but really cool, and it so happens. So we're going to write this half reaction right here and this half reaction right here. Now notice in these two half reactions I've included some other compounds that will enable me to balance it much easier. Because I do need all those elements in there. I can add in waters, I can add in hydrogens, I can add in oxygens for the waters, I can add in hydrogens with the hydrogen ion, but the other elements I really can't add in there. So I'm going to just throw those in there as those compounds, and let's see what happens. So for that top reaction, which is the reduction half reaction, the bottom one is the oxidation half reaction. So for the top reduction half reaction, I'm going to look at non-oxygens, non-hydrogens. And you should see that we have 1 iodine on the reactant side and 2 on the product side. So we're going to place a 2 in front of the KiO4. Now I have 2 potassiums on the reactant side and 1 potassium on the product side. I need a 2 in front of the KCl. Now I have 2 chlorines on the product side and 1 chlorine on the reactant side. I need to put a 2 coefficient in front of the HCl. Now, thus far, all I've done is balancing all the non-oxygen, non-hydrogens. Now I need to deal with the oxygens. So how many oxygens do I have on the reactant side? Because there are none on the product side. So how many oxygens on the reactant side? I have 2 times 4, that's 8. So for every oxygen that's unbalanced, I need to add a water. So I'm going to add 8 water molecules. All right. Now, on the product side, I have 8 times 4 hydrogens, okay? And then on the reactant side, I have 2 hydrogens. So I have 8 times 2, hydrogens, so that's a total of 16 hydrogens on the product side. So 8 times 2 hydrogens on the product side, so that's 16. On the reactant side, I have 2 hydrogens. So the difference between 16 and 2 is 14, so I'm going to have to add 14 hydrogens on the reactant side. Now I need to balance this for charge. On the reactant side, I have 14 positive charge. On the product side, I have a 0 charge. So I'm going to have to add 14 electrons to the reactant side. This is also an acid, as that hydrogen ion indicates, and as you should see that it's in HCl, that's hydrochloric acid. There's that 14 electrons that I was talking about. All right, now what we have done is we have balanced that reduction half reaction for charge and for mass. Now I need to deal with the oxidation half reaction for both charge and mass. But before I get to charge and mass, I need to balance all other elements first. Okay, so how many iodines are on the reactant side? 1. How many iodines on the product side? 2. So I need a 2 stoichiometric coefficient in front of the Ki. That will give me 2 potassiums, and how many on the reactant side, how many potassiums on the product side? 1. So I need a 2 coefficient for the potassium chloride on the product side. Now that gives me 2 chlorines on the product side. I have 1 chlorine on the reactant side. I'm going to put a 2 coefficient in front of the HCl. Now all my non-oxygen, non-hydrogens are balanced. I don't have any oxygens, so I don't have to worry about that, but I do have to worry about the hydrogens. I have 2 hydrogens on the reactant side, and I don't have any hydrogens on the product side. So I'm going to have to add 2 hydrogen ions to the product side like that. Okay, the net charge on the reactant side is 0. The net charge on the product side is a +2. So I'm going to have to add 2 electrons to the product side. And I've done that right here like that. All right, now this bottom oxidation half reaction is balanced for both mass and for charge. So now what I need to do is add up these 2 reactions. And in order for me to add up these 2 reactions, I need the electrons to cancel out. And they don't do that thus far. So, like what we have done many times before, in that top reaction here, in the reduction half reaction, I have 14 electrons. In the bottom oxidation half reaction, I have 2 electrons. So you really only need to multiply the bottom oxidation half reaction by a coefficient of a 7, and that's what we're going to do right here. So, we're going to bring the top equation down and just rewrite it. So I've just rewritten the top reduction half reaction. I didn't multiply that by a coefficient. If you wanted to, you could have multiplied by a 1 to satisfy that need. Okay, now what I'm going to do is multiply that bottom oxidation half reaction by 7. So I'm going to distribute that 7 over all the terms within inside the brackets there. So that will give me the following equation right there. Now you should see that I've kept the arrows in line so that I can separate my reactants from my products. Okay. Now the next thing that we need to do is check to make sure, before we draw that line in the sand, to check to make sure that our electrons do cancel out. And look, they do. I have 14 electrons on the reactant side for the reduction half reaction and 14 electrons on the oxidation half reaction that's on the product side. So are there any other things that we can cancel out? Well, most certainly the hydrogen ions actually cancel out as well. Is there anything else that we can cancel out? I don't think that there's anything else that we can cancel out, but there are some things that we can combine. So some things that we can combine are the HCl, and we can also combine the KCl. Okay, everything else is unique on this problem, so now is the time that we can draw that line. Oh, wait, we have that iodine. I forgot about that. We can combine the iodine as well. Everything else is unique in this problem. Okay, now what we can do is draw that line in the sand and then add these up. So again, the electrons cancel out, the hydrogen ions cancel out. Now what we have are our hydrogen chloride or hydrochloric acid, aqueous. We're going to sum those up, okay, and we're going to get the following. So we're going to get 16 HCl plus 2 KiO4 plus 14 Ki produces 8 iodine plus 16 KCl plus 8 water. Now again, This is your check, and this is critical, and you got to make sure that you do this check every single time. If you don't do this check, then you're really not completing the problem. So let's make sure that we have everything balanced. On the reactant side, we have 16 hydrogens. Okay, on the product side, we have 8 times 2, that's 16 hydrogens. On the reactant side, we have 16 chlorines. On the product side, we have 16 chlorines. On the reactant side, we have 2 potassiums plus 14 potassiums. That's a total of 16 potassiums. On the product side, we have 16 potassiums. On the reactant side, we have 2 iodines plus 14 iodines. That's 16 iodines. On the product side, we have 8 times 2. That's 16 iodines. On the reactant side, we have 2 times 4 oxygens. That's 8. On the product side, we have 8 waters. That's 8 oxygens. Okay? And I think we've balanced everything thus far. We've dealt with the potassiums. We've dealt with the iodines. Everything's balanced. So we can reduce this, and that is critical. You should see that there's even stoichiometric coefficients on all of these. And having there being even stoichiometric coefficients, we must reduce to the lowest coefficient possible. Okay? And that means that we're going to get an odd number on one of these, more than likely. So after reduction, we get the following. 8 HCl plus KiO4 plus 7 Ki produces 4 iodines plus 8 KCl plus 4 waters. And this, of course, if the top one balanced, this one obviously balances. And you should see that in this bottom yellow balanced equation with the lowest possible stoichiometric coefficients, you should see that there's an odd number in the Ki, that's the 7. And there's an even number, that's an 8 in the HCl. So you cannot furtherly reduce this down anymore. You can label this as the reduction and the oxidizing agent as being KiO4 and the oxidation reducing agent as the Ki. Remember, you are only labeling the reactants on the reactant side for a redox equation. Okay? I'm hoping that you enjoyed that. That was a great, cool, awesome problem. I am the crazy hat chemist, so of course I got myself a crazy hat. I love this hat. I need like a super cool car with this kind of hat. If you enjoyed that video, give me a thumbs up. Please subscribe to my YouTube channel. Pass on my YouTube channel to all your cool chemistry colleagues in your class. Okay, and you can always Google me and then find my website, of which you can get yourself a cool sticker for your hydro flask or some other flask, or you can get yourself a cool t-shirt if you want it. So I hope you have a fantastic day, and I will see you next time for another cool chemistry video. Bye for now.